Today we are going to do chapter 10.1, which is the law of sines. Now to prove the law of sines, here's what we're going to do. I have drawn a triangle here. Okay, it has two angles at the bottom, alpha and beta. It has a height, which means this is a right angle triangle. This picture is also in your book that I'm repeating here. And then so then let's consider what is sine of alpha. Then sine of alpha is going to be equal to h over b, right? So sine of alpha is equals to h over b. Opposite divided by hypotenuse. And then sine of beta, on the other hand, is going to be equal to h over a. Okay, so sine of beta equal to h over a. Now from this simple thing, beginning, we are going to derive the law of sine. So then from this equation, we get h then equal to b times sine alpha. Okay, just move the b up here. Then h equal to b sine alpha. And h also equal to, from here, a sine beta, for the same reason, a sine beta. And that's it. This is the law of sine right here. Okay, we already did it. That is, put it another way, is the sine alpha, if we move the a down here, sine alpha over a equals to sine beta over b. Now this is, in other words, in any triangle, the side a is or put it this way, the angle sine alpha divided by the side that opposite it, which is a, is going to be equal to the angle beta, a different angle, sine of beta divided by the side that is opposite. And similarly, if there's a third angle here, we'll call the third angle here gamma. There's gamma here. Actually, that's not gamma. Let me write down gamma here. Here's gamma. Let me draw it there. Okay, gamma looks like a tree or something like that. Anyway, so then if there's a third side C to the triangle, then the third side works the same way. Okay, that is sine of gamma with the same argument, gamma, is divided by C. Is these proportions are all the same. So with these proportions, we will be able to solve various problems that is based on some kind of triangle. So these three things equaling to each other is called the law of sine, and that is what we're going to do in this section. So having said that, let's remember this principle. Okay, and where would I remember it? I guess I will write it down. Maybe. Let's see, I'm out of space here. I'll write it down right here, okay? All right, I wrote down the law of sine right there. So sine of alpha over a equals the sine of beta over b, remembering that alpha and a are related in the sense that they look at each other, okay? A is the side that corresponds to the angle alpha, and b is the side corresponding to the angle beta. And then the third one works the same way, but we'll just write down 2. 2 is enough. That's because it should help you remember the third one. And so let's look at the bottom of the page where this law is being repeated as we have written on the board. Okay, sine alpha over a equals to sine beta over b, which is sine gamma over c. We can also flip it around. The equality works too. Okay, either way is fine. But most of the time we do it this way. I don't think we ever flip it around, to be honest. But it is possible. Okay, nothing wrong with doing that. But this is probably the most common way of using law of sine. So let's turn to the next page and look at example 1, which I will draw on the board. So let's look at example 1 on page 896. I have drawn the same picture here that is in the book. We have a triangle. The law of sines is all used with triangles. It's a relationship with a triangle's angle in relation to its sides. So we have a triangle here. And the thing I need you to remember is inside the angles of a triangle always add up to be 180 degrees. That is, I don't know where that was taught, but that's the thing. Okay. So anyway, being that is the fact, then here's 50 plus 30. So that means this angle has to add. 3 angles has to add up to be 180, which means this angle had better be 100, right? Because 100 plus 50 plus 30 does 180 degrees. So that angle is 100 degrees, but now what? Let's give these things a name. Let's call this side. Does the book already gave it a name, so I will use the same name that they use to be consistent. This side is called C, and this side is called B. Now, and then we just use the law of sines, and then we'll be able to figure stuff out. Okay, that is by the law of sine right over there. Then 10 is opposite the angle 50. So we have sine of 50 degrees divided by 10 is equal to sine of 30 degrees, sine of 30 degrees divided by C, and then that also equals to sine of 50 degrees. No, not 50, we already did 50. Okay, sine of 100 degrees, and divided by B. So from these 3 equations, we'll be able to figure out what C and B are. That would mean that C, looking at these 2 equations, then C, let's move C, well, I guess these are in 2 different lines, make it a little bit harder to see. Well, C would be move C across the equal sign on top, okay, and divide by sine 30. That is C equal to, if you move C up over here, okay, move C up, and then so we have sine 50 over here, sine 50 degrees divided by 10. So I moved C over there, and then move the sine 30 down here times the sine 30 degrees. And that equals to C. And then you're right. And B is similar, that we move the B across the equal sign up. Wait a second. I need to be, yeah, I should be more careful with this so that I don't tell you the wrong thing. Because once C is moved to the other side, it's next to this. So this thing needs to be flipped around. Sorry about that. Let me not say something weird here. All right, see, I wrote the same thing over here. Now I can see it much better, okay? So now we will do moving around without messing up. I mean, I will. So we need to move the C over here. So C will be up here, and everything else will be moved to the other side. So the sine 30 is still here, sine 30 degrees. And then sine 50 will be moved down. Okay, move this thing across the equal sign down. And then, so that's sine 50 degrees. And then move the 10 up, so the 10 is being multiplied by 30. And then that's, what is that? That's called cross multiplication, okay? So, and then, so this times that, and this times that, and then you push the 50 back. Well, basically, push everything across the equal sign to the other side under the division line, okay? If it's on top. If it's on the bottom, then push it across the equal sign to the top of the division line. So you do this cross multiplication thing. Anyway, C is moved through the equal sign on top. So C is right here, whereas the other stuff is where they should be. So now that we have done that, the next job is pull out the calculator. If I can find it, I don't see it. Let me find it. Actually, before we do the calculator, do the same thing over here, okay? Doing the same thing over here because with B, we do the same thing with B that we do with C. Then B equals to, move the B up here. That means there's the sine 100 degrees, that stays. And then the sine 50 get pushed on the bottom, just like this one. Sine 50 degrees is down here. And then the 10 pushes up to be multiplied to be the sine 100. All right, so that should do it. And so we have, let me get my tablet back. Okay, so now let's punch that out on the calculator. So first, let's calculate C. I need my calculator in degree form. I think it is. So let's do that. So sine 30. Let's type it in. Where's sine? Sine 30 divided by sine 50, and then I forgot to put in the parentheses there. All right. Divide by sine 50, and then times 10. That equals to something. 6.5. All right, that sounds about right. Let's check the book. Is it 6.5? Yep. C equal to 6.5. Next, sine 100 divided by sine 50, and also times 10. I forgot to put the parentheses in again. So sine 100, close parentheses, divide by sine 50, close parentheses, times 10, okay. That equals 12.9. Is that what the book says? Is there a 12 Yep, there is. So B is 12.9 and C is whatever it is, okay. And we are done with example 1. And that is that. All right, so next, let's look at the next example. Example 2 on the following page after I erase the board. Next, let's look at example 2 on page 897. We have a triangle here, which is drawn in your book as well. We have some angle here that's 35 degrees, and then we know two sides. Okay, so we have these two possible sides, and then some angle, and we need to figure out, well, the rest of it. So the first thing we're gonna do is by using the law of sine to figure out what this angle is right here. This so by law of sine, of course, it says that by the law of sine we have. I'll write it, let me see, right over here. Sine of alpha, okay, this angle, which is 35 degrees, divided by the side opposite alpha is 6, okay, 6 is A, equal to sine of beta. We don't know what it is, but we'll figure that out in a moment. Sine of beta, that's this one, the opposite side is 8. Okay, so with that, we're able to find beta, and so let's do that right now. To solve this equation, then sine beta equals to this thing, sine of 35 degrees, and then divide by 6, and we just have to move 8 across the equal sign on top. Okay, so that things always get moved across the equal sign and to the opposite side of the division line. So we move across the equal sign up and across the division line in the cross manner. But anyway, so this is sine beta, which means that beta equals to if we get rid of this, beta is equal to arc sine, that is sine inverse of all the stuff. Okay, so this is beta. So let's forget the sign. So that is the value of beta, and let's crank it out right now on the calculator. To calculate sine, so to beta equals to, we'll punch in sine inverse, which is shift. My calculator is shift sine. That gives us sine inverse. Okay, it has parentheses, and then we'll type in 8 times sine of 35. Close parentheses. No, let me not forget that this time. And then divided by 6. Divide by 6, and then close parentheses again to make sure that should be okay. And so sine inverse should give us an angle of 49 degrees, 49.9 or so. So beta equals 49.9. Now there is a, however, that is that's only one possibility. The other possibility is when sine value equals to something, there is that is from the previous section. We learned that when sine alpha equals to something, okay, there is to solve for it. There's another one that on the other side. that is 180 degrees minus this thing. Like say if this is beta here at 49.9, there's another one on the other side that has the same value of sine. That is, this angle here, the fat one, is equal to 180 minus beta. So the other angle is 100 beta, also equal to 180 degrees minus the 49.9. The reason is because both angles, if you type in the sine, will give you the same answer. Okay, both will give, and that's why when you solve for beta, there are two possibilities, because both angles have a positive sine value, because the y-axis is positive on both sides in quadrant 1 and quadrant 2. So anyways, these are both possibilities, and the other angle then would be the possibility for beta would be the 49.88, well, minus 180. I mean, you minus 180, so the other beta is 130 point something. It also, that's the second solution, is 130.11 or something like that. Anyway, so that is the second beta. And what else do we need to do? So we know what beta is the 130, is 40 or 130. So the triangle has two possibilities, but the way they're drawing it, we assume that they mean they only want this one. Okay, because they're implying that the triangle has an obtuse. This is called an obtuse triangle. Well, it used to be called obtuse. I think your book now calls it oblique or something. Well, I don't remember what it's called right now. We'll see it in a moment, I'm sure. Is there a word that's called obtuse and big? Yeah. See, the angles that are less than 90 degrees are called acute. And the ones that are bigger than that used to be called obtuse, but I think the book might call it something else. Let's see. Did it say oblique? I can't find it right now. It's not important what it's called. The point is, this angle looks like it's over 90 degrees. So we'll choose this one as the one that the book wants. But if we didn't know that it's supposed to be over 90 degrees, then either answer is acceptable. Okay, so now given that we choose this to be the answer, then we can figure out what the third angle is by taking this thing and add that one, and then subtract by 180. Okay, to see what the difference is. So the gamma is roughly whatever that is. Let's see, 165, right? Let's say this is 130, that's 35, there's 165. That's about 15 degrees away from 180. So gamma would be about 15 degrees. And then with that, we are able to calculate, once we know the angle, we can then calculate this third side, what it might be. That is with the same principle. That's the sine of 15 over this side, just like we did before. Okay, this is equal to sine of 15 degrees, 15 divided by the side, we'll call this side C maybe. Okay, so this is C, and with that we can calculate C like we did in the previous example. So please finish this as part of your homework, example 2. Yeah, let's see, what is the top? Well, whatever. The point is, sometimes there are two possibilities is what this is. Yeah, see, the book calculated gamma to be at 14.9 degrees. So that's that. And so please finish doing that, okay? And then we will move on to example 3. That is, all right, and what are we doing in example 3? We have, let me draw this out. So anyway, but I should mention that this is, now we're on page, I've got to write down what page it is. We're on page 899, example 3. But before that, I want to mention that I was worried about what the angle was called. But on the top of the page, it does say that an angle over 90 degrees, it is called an obtuse angle. So, and I must have seen something else, and when I thought they said something about oblique. Maybe not. So anyway, and let's move on to example 3. We have we have a triangle, okay? We have 85 degrees here, and 12 for that side, and 9 for this side. Now with that information, we can use the law of sine over here to derive what this thing is, because we know the side and the angle for this pair, right? And we know the side but not the angle for this pair, so we just toss that one in and write it out. So by the law of sine, sine of 85 degrees divided by its side, which is 12, is going to be equal to sine of beta, that we don't know what it is, but we're going to find it, and divided by its side, which is 9. So that information is enough for us to find beta. So let's do that. Okay. So then sine beta equal to this stuff. Move the 9 up here. Across the equal sign on top, also across the division line. So this becomes 9 sine 85 degrees divided by 12, and then we're going to take the sine inverse. Get rid of that. Sine inverse. Sine to the power minus 1. That is sine. It's not to the power. It's just written that way. So sine, the inverse sine of all this stuff is going to give us beta. Okay. So let's do that. Let's see. So shift sine of, no, we don't need another parentheses. One's enough. 9 times sine of 85 degrees, close parentheses, divided by 12, close parentheses again. That should do it. That's 48 something. What's 48? Degrees, I guess, because we're talking about beta. So beta is 48 degrees right up here. And that is, that's just for beta, is 48 degrees. So beta is 48. And then so by now you can calculate alpha by taking 180 degrees, dividing and subtracting that, and that will give you the third angle. And once you find the angle, then you can find what A is the same way, the same way we find the other stuff. That is, use the law of sine again. I think I will do that right now. Okay, so once we've that is about 48 degrees, then let's see, then the alpha is 180 degrees minus the stuff that equals to, I'm just going to copy down what the book says to save a little bit of time. The alpha is 30, what? Why is this negative? 48, what is alpha anyway? And the book says a lot of stuff. Maybe I should just do this myself. So then alpha is, let's just say 180 degrees minus 85 degrees and minus 48, and that equals to I don't know what that equals to. Let's use our handy calculator for that. 180 minus 85 and then minus 48. That equals to what? 47 degrees. All right. So is there 47 degrees in here? What's the decimal point? Maybe it's on the next page. Where's the 47? Alpha is 46.7. All right, we'll take that one. Okay, so alpha, we'll take alpha is 46.7, 46.7, and that will help us find A, because by the law of sine, then sine of 46.7 degrees divided by A is going to be equal to, well, which one do we pick? Doesn't matter. We'll pick this one, because this one, no, this one is given to us, equal to sine of 85 degrees, 85, and divided by 12 degrees. So then A then equals to, move the A over here. So A then equal to, writing on this side, sine of 46.6. Sine of 46.7 degrees divided by, what am I doing? I'm moving A over here, right? And then divided by, move this thing down, okay? I moved A over here, so then that better come down, sine of 85 degrees and then this 12 will be moved up, so that times 12. Everything go across the equal sign to the opposite side, okay? And what's on top will go on the bottom, and what's on bottom will go on top. Now, having said that, let's now figure out what that is. And so A then will be equal to 12 times sine of times, I don't need the parentheses, let's get rid of that. 12 times sine of, where's sine? Sine of 46.7, close parentheses, divided by sine of 85, close parentheses, and that equals to something, 8.7, etc. And what was this? A. So we'll figure out what is, where's A? 8.7, yep, 8 is about 8.8, that's good enough. Okay, so that is example 3. So next, let's look at example 4. Next, let's look at example 4 on page 900, where we're supposed to calculate stuff of this triangle where one side is 4, and the 4 faces the angle that's 50 degrees, okay? And then another side is 10, and we need to figure out what that angle is. So again, we are going to use the law of sine. We have one trick up our sleeve today, and we're going to use it for everything. So by the law of sine, then sine of alpha divided by its side, which is 10, has to be equal to sine of 50 divided by its side, which is 4. Okay, so each one is the law of sine says each angle can be divided by its corresponding side, and that should be the same each of all 3 angles. So to do that, then sine alpha then equal to 10 times 10 over 4 times sine of 50, and let's figure out what that is. Okay, and we will do that by using our cool little calculator. And so and now we'll type that in, 10 divided by 4, and then times sine of 50 times, oops, I forgot to type in sine, times sine of 50, close parentheses, that should do it, right? And then we've figured out that is equal, so sine alpha has to be equal to 1.9, and that is not acceptable because it's not, if you try to do the inverse of sine inverse of this value, the calculator will have a fit, because sine values does not go over 1. Okay, sine goes between 1 and negative 1 always. It doesn't ever become that. Now why are we running into a problem? That's because the problem is asking too much. This angle is too big for the side to be, this side is too long. For a side to be 10, this angle can't be that big, okay? It's too big. So there's no triangle that will fit this requirement. The requirement is not reasonable, and it cannot be done, okay? So that is problem 4. So next, let's go to page 901, where we're going to consider calculating the area of the triangle. Here's an oblique triangle. The word oblique just means the triangle is not a right angle triangle. So we have right angle triangles, and everything else is called oblique. And that must be where I got the idea of oblique. Anyway, so here's our oblique triangle, and we need to calculate its area. Okay, and to calculate the area, we need to know what the height is. And what is the height? The height then is equal to well, has to do with sine theta in the sense that the height divided by c is equal to sine of alpha, right? That is the definition of sine alpha. Is opposite divided by hypotenuse, being that if this is the height, this is a little right angle here. So sine alpha is going to be h over c, or put it another way, h is equal to sine alpha times c. Maybe I should write the c here. Maybe that's too ugly. Let me fix that. Okay, I fixed it. H equals the c sine alpha. Now it's slightly less ugly. Okay, so h equals the c sine alpha here. So then the area of the triangle would be equal to base times height over 2. Okay, so is the area then equals to, I'll write down A for area. Area equals to 1/2 the base, which is B, times height H, and we can write H as C sine alpha. And that is the area, that's one formula for area of a triangle. It's just the original formula, but we use a sine as part of it. And the area, you notice, area is 1/2 of area is 1/2 of BC sine alpha, and that applies to the other sides as well. Doesn't matter which one. That is the area of any triangle. Okay, let's draw a triangle, and you have one angle there. Then and call the angle alpha. Then the two sides, the adjacent sides of the angle, let's call them B and C. And the area, you can just, once you know these things, then you can calculate the area. The area will be 1/2 B times C times sine of alpha. And that's the formula for general formula. And remember, BC isn't just any old side. The BC has to be the adjacent side of the angle alpha that you're taking the sine off. Okay, so BC has to be the two sides right again that alpha is made up with. That is, BC is alpha's two sides. All right, so having said that, let's try one of these things. Example 5 at the bottom of the page. And then let's see, we have a triangle with two sides and then an angle. All right, so the two sides we have a triangle with two sides. Well, it doesn't matter. When we don't have to draw it out. The point is the area. We're supposed to find the area. Then area equals to the 1/2 times the first side, okay, which is 90, times the second side, which is 52, times the sine of whatever angle's in between. And the angle is 102 degrees. We don't have to draw it out. Just to make sure that the facts are straight. That is, the angle has to be the angle between the two sides. If it's a different angle, then we can't use the formula unless we figure out what the sides are. Okay, so the angle, just make sure the angle is the angle between these two sides. Now once we made sure of that, then let's pull out the calculator and let it do its magic. So we have the area equals to 1/2 1 divided by 2, close parentheses, times 90 times 52 times sine of something, sine of 102 degrees, close parentheses, and that should do it. Why is my area so big? Let's see, but that's not necessarily bad. Okay, let's see if 2,289, and that's correct. So that's example 5. And next, let's look at example 6 on the following page. I still have some space here. Okay, example 6 says that we have some kind of object, airplane, that is in space. I mean, not in space, that's up there, okay? And then we can measure the angle of elevation looking up at it, as the picture shows. I'm on page, example 6 on page 902 in your book right here. And as you can see the picture, so here's and what are we trying to figure out? Actually, maybe I should figure out what are we trying to do here. Find the altitude of what? Of the aircraft, okay? Find the altitude of the aircraft. All right, fine. So we're trying to figure out how tall this thing is. That is the height of this thing. We know that these two objects are 20 miles apart, and then but then how tall is that? Okay, to figure that out, let me think. And that's 15 degrees, and the distance apart is 20 miles. All right. Okay, so let's look at example 6 on page 902. We have to figure out what A is, okay? Because once we figure out A, then we can figure out the height by the sine relationship, because this opposite divided by a hypotenuse is equal to sine of 15. So we just have to figure out what A is by the law of sine. And to do that, we need to know this angle. What is that angle? that angle will be 100, we'll call this thing gamma, maybe. Gamma then equal to 180 minus the 15 degrees and minus the 35 degrees, because the sum of the angle of a triangle is 180 degrees. So that will give us something, okay? That's like 50, so that would be 130 degrees, I think. All right, yeah. So if gamma is 130 degrees, then we're supposed to calculate A. Then A would be equal to, let's see, to use the law of sine right here, okay? So sine of 35 degrees divided by A is going to be equal to sine of 130. Let's see, 130 degrees divided by 20. All right, so that's that. That means A equals to, so let's move A up there. So A is up there. And then move the sine 35 stays, 35 degrees. Move the sine 130 down here, 130. And then move the 20 across up. So 20 goes up here. All right, so that should do it. That should give us the A. And then, but that's not all, okay? And then this is H. And remember that H divided by A, opposite divided by hypotenuse, equal to sine of 15 degrees. So which means H is going to be equal to A times sine 15. So if we take A times sine 15 degrees, that will be equal to H. Let me write that down a little better. So A times sine 15 degrees is going to be equal to H. Equal to H. So this thing need to also multiply by sine of 15 degrees. 15 degrees. Okay, so all this stuff will be equal to A times sine 15 degrees, and that will be equal to H. So let's do that, and then we are home free. So doing this thing, okay, I think you can see it okay. So we have sine, let's start with this sine 15, where's sine? Sine 15 degrees times 20 times sine of 35 degrees divided by sine of 130 degrees. That should be equal to H. What's H? H is 3.8. All right. Is that what the book says? Let's check to make sure that I didn't make a mistake. Okay. 3.88. What did I have? 3.88. That is correct. So that is how high the airplane is. That's talking about miles. Okay, 3.88 miles. So that's about right. So that is the end of this section. So for homework, on page 903, please do this bunch of stuff that I assigned. Okay, there's quite a lot of them, over 20 problems. So I won't be reading them out. I think most of them are fairly short. You just have to remember this one principle, and then and there's a minor side that says, by the way, we also know the area of a triangle. You can do it this way, which is 1/2 area of triangle is 1/2 BC sine alpha. That is yeah, and the 1/2 of the two sides times sine of the angle that's stuck between the two sides. And so please memorize this law of sine. Okay, it's a fairly simple thing to memorize. It's parallel, and then once you do that, you can do all the homework. So please go do your homework, and when you're done, I want to talk about some of them. So next, now that you are done with your homework, let's look at problem 51. 51 says that we have a radius here, and then which means these two sides are the same, okay? And then there is 8.3 that faces 110 degrees, which means the rest of it is what's left is 70 degrees has to be evenly divided, because if this is called an isosceles triangle, which have equal sides. If it has two equal sides, then these are called the base angles, and they have to be the same. So what's left of 70 degrees has to be divided evenly between these two, so each one will be 35 degrees. So once we know that, then we can figure out what r is with the law of sine. Okay, so then law of sine, I guess I'll flip it around and do it the other way. It might be a little faster. So then r, flipping the law of sine around, which is still the law of sine, we'll have 8.3 divided by sine of 110 degrees. It will be equal to r divided by this one, r divided by 35 degrees, which means not 35 degrees, sine of 35 degrees, which means r equals to this stuff times the sine of 35 degrees. Okay, so let's do that. Okay, then I don't have to write out so much stuff. To calculate r equals to this stuff times the sine of 35. So let me type that out. 8.3 divided by sine of 110 degrees. Okay, and then we just have to multiply by sine of 35, and that should do it. So let's see what that equals. That equals to 5 point whatever. And then we have to multiply by 2, because it asks us for the diameter, which is 10.1. And that is what the back of the book says. Okay, so that is the right answer. Next. All right, so next let's consider problem 53, which has a triangle drawn in the book, okay, which I redraw here. We have an angle, we have a side that's 12, an angle that's 53 degrees, and over here another angle 44 degrees, and then we're supposed to look for this length A to D, and which is the length A. Okay, so then let's apply the law of sine. Let's flip it around again, and because that might reduce the amount of writing I have to do. So then A divided by the law of sine, flipped around. So then A divided by its sine of its opposite angle will be A divided by sine of 53 degrees. It's going to be equal to the 12, it is opposite angle, which is 12 divided by sine of 44 degrees. So that means A equals to this stuff, okay, times the sine of 53. And that should give us the answer. And let me then do that right here. A is equal to sine of 53 degrees times this stuff. Okay, so let me type it in. Sine 53 times, okay, sine times 12. And then divided by sine of 44. Okay, and that is that should be times 12 divided by, and that should be it. And A equals to 13 point something. Okay, then let me see, what problem is that? 53, 13.8. Yep, that is correct. Okay, so that is one quick answer to a. And then you might wonder, what's that 13 for? That's just here to throw you off. It's not for anything at all. Okay, so next. I will finish this section in the next video.